to one and all. Here, welcome to the academic year 2020-21. So now coming to our structural analysis 1, we have studied about, we have learned from strength of materials concepts. In the strength of materials, we have seen how to analyze a beam, which is a determinate structure. So we have classified the structure as, first of all, stable structure as well as unstable structure. In the stable structures, we have seen that that means the structure, the unknown reactions and the number of equations of equilibrium. That means the number of unknown reactions which are greater or equal to the number of equations of equilibrium. So these equations of equilibrium we have seen basically as per our planar structure, that means two-dimensional structures as well as three-dimensional structures. That is plane structure as well as space structures or space elements. In the plane structures, we have seen that the equations of equilibrium are sigma fx is equal to 0, sigma fy is equal to 0, sigma m about any point is equal to 0. Whereas coming to space structures, sigma fx is equal to 0, sigma fy is equal to 0, sigma fz is equal to 0. That means you will be having the forces along x, y and z directions, summation of the forces along x, y and z directions, they are equal to 0. And moments about point x, moment about points y, that is summation of the moments about x, y and z is equal to 0. So total 6 equations of equilibrium you will get in case of space. In case of plane, you will get 3 equations of equilibrium that we already studied in our strength of materials 1. In the strength of materials 1, we have seen what is the difference between indeterminacy as well as determinacy. So basically we studied about what is meant by determinate structure, what is meant by indeterminate structure. So in the indeterminacy, once again we further classified to static indeterminacy as well as kinematic indeterminacy. So we have seen what is the meant by static indeterminacy as well as kinematic indeterminacy. We have solved the problems related to cantilever, basically proper cantilever beams as well as fixed beams. So we analyzed them, we calculated what is the shear force diagram, what is the bending moment diagram for a particular type of UDL, for a point load, for a triangular loading, for a trapezoidal loading, for a concentrated moment. So for a particular type of loading, how the shear force diagram as well as bending moment diagram varies. That we have seen using from our principles of indeterminate structures. Then moving forward, we studied about analysis of plane trusses or frames. So we have seen how to analyze a pin jointed frame using 3 concepts. One is method of joints, method of sections and tension coefficient method. Once again, please be familiar with all these subjects, all these topics. That will be helpful for our structural analysis too. Now, moving forward, in the 3rd unit, we have seen how to analyze a structure, that is strain energy concept is brought, that is energy method. Using the strain energy method, we have observed how to analyze a structure, that means how to calculate the deflections in at a particular point using strain energy concept, that is the energy U is equal to integration of m squared by 2ei into dx. So this is under bending. I am saying that strain energy stored in an element of a structure under bending. Similarly, we have seen under axial loading what is the strain energy capacity. Then we have observed how to analyze a structure which is indeterminate. That is, examples are continuous beams using slope deflection method. So using slope deflection method, we have analyzed a structure. Then we have observed the structures related to what are the we have seen in the 5th unit. We have seen how to analyze that means using influence line diagrams as well as moving loads. For example, on a beam, when the moving loads are moving and when the structure is subjected to the pins, a structure is there on that, where you will get the absolute maximum bending moment for a particular type of UDL is moving. So we have seen that a point load is moving single load and a series of concentrated loads, then the moving of a UDL. All these topics we have seen in our structural analysis 1. Now, coming forward to the subject, in the structural analysis 2, we will learn these 5 units. In the first unit, we will see two-hinged arches. So first unit is two-hinged arches. If you remember, in the third unit, we have seen three-hinged arches. Three-hinged arches, the topic we have studied. Now coming to here, what is meant by two-hinged arches? And in the same unit, we will also study about moment distribution method. So this is structural analysis 1. We have seen three-hinged arches. Three-hinged arch, it looks like this. If the screen is not visible, then give me a message in the chat box. So the three hinges are provided here. So when the three hinges are provided, now you can see how many unknown reactions are there. This is A, this is B, this is C. So these are reactions will be there. We have written this is VA. And here this is VB, vertical forces. And here horizontal reactions are there. HA, we call them as horizontal thrust. And here HB will be there. Now total how many unknowns are there? There are total 4 unknowns are there. The unknown forces are 4. So in these unknown forces, HA, VA, HB, VB, 4 unknown forces are available. Now coming to here, how many equations of equilibrium are there for a plane structure? So for a plane structure, we are having 3 equations of equilibrium, that is sigma fx is equal to 0, sigma fy is equal to 0, sigma m about any point is equal to 0, and additional one equation will be there, that is a compatibility equation, that is sigma moment at c is equal to 0. So there are 4 equations that are available. 4 minus 4 is equal to 0. So total 4 minus 4 is equal to 0. So you can see that means the structure is statically determinate structure. That means the number of unknown reactions minus the number of equations of equilibrium that are available, and if it is equal to 0, we call it as the statically determinate structure. Whereas coming to two-hinged arches, in this two-hinged arch, if you observe this like this, it will be like this. So there are at the hinges are provided at the springings. Remember the terminology we used in our class. We call them as the supports of an arch. We call them as springings. So the reactions at A and B, so the two hinges are provided at the springings. Now here, this is vertical force VA is there, and horizontal force HA is there, and here vertical force VB is available, horizontal force HB is available. Now total how many unknown reactions are available here? 4 unknown reactions are available. Corresponding to these 4 unknown reactions, we will be having how many equations of equilibrium? 3 equations of equilibrium only. Sigma fx is equal to 0, sigma fy is equal to 0, moment about a point is equal to 0. That means there is no hinges provided here at the crown point. So the one additional equation from the compatibility you will not get. So 4 minus 3 is equal to 1. So the degree of static indeterminacy of a two-hinged arch is 1. I may give you the notes, but however, try to maintain a running notes. The points, whatever I am saying, take a book. It is not an introduction class. So take one notebook, take a pen, and try to note down the points, whatever I am explaining. Okay, so this is 4 minus 3 is equal to 1. So the total equations of equilibrium, that is 3 available. So the degree of static indeterminacy. So what happens is, what does this one indicates? That means it indicates that you require one additional equation to solve the unknowns. That one additional equation we will get with the help of either energy concepts or by displacement concepts. That we will see later. If you go to the two-hinged arches chapter, I will explain you. So that is how we will see what is the shear force diagram, what is the bending moment diagram, what is the you can understand in the three-hinged arches at a given point. If you see, there will be three things will be there. One is normal thrust, radial shear, and the third one is you will be having a moment. So the at any point, if you take the section at that point, you will be having normal thrust, radial shear, bending moment. These points will be there. Okay. Now that we will see if you start a three-hinged arches chapter. Now coming to moment distribution method. So moment distribution method, why should we go for this moment distribution method? In our fourth unit of structural analysis 1, we studied slope deflection method. The word itself is saying slopes and deflections. So what we have taken at that point in the slope deflection method, we have taken MAB is equal to, if you remember, can anyone of you remember that one? MAB is equal to MFAB plus 2EI by L into 2 theta A plus theta B minus 3 delta by L. Yes or not? So we used to write MAB is equal to MFAB plus 2 EI by L into 2 theta A plus theta B minus 3 delta by L. So using this minus 3 delta by L. So we use it to calculate the unknown reactions in a particular beam. The unknown moments are to be calculated using our slope deflection method. So this is summation of fixed end moment plus rotational moments, and this is delta is nothing but due to that is fixed end moments plus rotational moment plus displacement moments. We call it as the moment at any given point. Now we use that is slope deflection method. It takes a lot of time to calculate the unknown reactions. So in a better way, what we can do, rather than going for a longer duration, that means we can go for iterative process. So that iterative process that will be done by moment distribution method. So this moment distribution method, it simplifies the method that is being done by slope deflection method. So it will minimize even like efforts. So within a short time we can analyze our problem. So that we will discuss in moment distribution method. Similar way, so this moment distribution method or slope deflection method or the Kani's method, all these methods we call them as displacement methods. We call them as displacement methods, and the strain energy method we call them as force methods. That means ultimately all these methods, the purpose is to calculate the unknown reactions. So what happens when I get these unknown reactions? These unknown reactions and these maximum bending moments, they will be considered, and after the analysis you will go for a design. So parallelly RCC subject will be start to you to analyze the structure. That means to design the structures. From the analysis you will move forward to design the subject. So here this third unit, second unit, once again another method is there, Kani's method. This Kani's method, it is also iterative process, whereas what is the difference between these two methods is either slope deflection method or moment distribution method, we will analyze only the beams and frames. We will analyze the beams or frames, which are frames of That means if I want to go for a frame like this, that means there are 2 stories are there and single bay. And that means only we have seen in your slope deflection method, if you remember, we have seen non-sway as well as sway problems. But if I want to analyze a frames like this, multi-story frame, then the method which one is helpful is Kani's method. So this Kani's method will be helpful. Now, next one is how to analyze a cables and suspension bridges. So if you see in our Karimnagar, on the river of Maneru river, you might have observed the cable bridges are being constructed, right? So what are the forces that are being there in a cable? So whether there are, which nature of the force will be there, either it is a tension or compression. So majorly cables will be subjected to tensile forces. So how the cable bridges or suspension bridges are to be designed, how to analyze them. Basically, we are studying in the structural analysis how to analyze a cable bridge as well as suspension bridges, which are indeterminate structures. That we will see in our structural analysis 2, unit number 2. Now another one is unit 3, approximate methods of analysis. These approximate methods are nothing but cantilever method, portal method. There are different approximate methods that are available. So something like you are having a multi-story structure. Take your 2-story house. So how to analyze this 2-story house? I cannot go for slope deflection method. Why? Because you know that when the unknowns are more, if they are more than 3, then analysis of slope deflection method or either moment distribution method, it takes longer time. It is difficult to analyze. We can analyze, but it takes a lot of time. It is a tedious job. So rather than that, to do in a lucid way, that is in an easier way, we can go with the help of approximate methods of analysis. These approximate methods of analysis, they are available, like cantilever method is available, portal method is available. Using them, we can calculate what are the bending moments as well as shear forces. Matrix methods of analysis is quite interesting chapter. If you know this chapter very well, then you will be perfect in your structural analysis. So these matrix methods are nothing but there are 2 methods out there. One is stiffness method, another one is flexibility method. So this stiffness method and flexibility method, these methods are useful to analyze our unknown reactions. Unknown reactions, if I talk, unknown forces and moments. So that is reactions RA and RB, moment MA and MB. That basically I call it as unknown reactions or unknown forces. Now these matrix methods of analysis, either flexibility method or stiffness method. So if you see, stiffness method is a displacement method, flexibility method is a force concept, a force method. Okay, so here matrices. So we should know A inverse, how to calculate inverse analysis. Everything we should be familiar with that one. Now coming to the next one, influence lines for indeterminate beams. Influence lines for indeterminate beams. So first of all, we should know how to draw the influence line for a determinate structure. In our first structural analysis 1, I tried to explain the concept of how to analyze, how to draw the influence line for a reaction RA, reaction RB. Then we have moved forward how to calculate the maximum bending moments, absolute bending moments, and all these concepts we try to learn using our influence line concept. I think most of the people, they skipped. Why? Because it may not be, we can leave for our choice. But however, these influence line concepts, they are useful to analyze quickly. That means if a frame is given, if a structure is given, I can directly calculate, instead of going one by one, I can directly calculate what is the force in a particular member. I need not go one by one. So these influence lines are very helpful for moving loads basically. So this is how the entire structure of structural analysis is divided. So this structural analysis tool is basically meant for indeterminate structures. So we will be analyzing indeterminate structures. So the indeterminate structures like proper cantilevers, fixed beams, continuous beams. So these first basically proper cantilevers and fixed beams, they were analyzed in our structural analysis 1, and continuous beams were analyzed with the help of slope deflection method. Now we will see another two methods are there, moment distribution method and Kani's method. They will be helpful to analyze beams as well as frames. Beams and frames that will be analyzed. And now coming to two-hinged arches, we studied three-hinged arches. So what I instruct you people is, once open the notebook of structural analysis 1, just go through the subject very quickly.